we're going to pick up with question 3 from the differential equations worksheet. This question is asking us to find the general solution for the equation dy dx is 5x squared y. So our general solution means we're going to have a plus c in our answer, so we get to save a couple of steps. Before we can find the general solution, though, we do have to group our variables. So the very first thing that I notice here is that on the left I have my dy over dx, and we're going to be seeing that in almost all of our differential equations. It's the slope of something, the first derivative, so we're going to be seeing dy dx. I can't integrate dy dx as it stands. I can't actually deal with this dx in the denominator of a fraction ever. I can't do dx to the negative 1 power and find out what that means, because this just means with respect to something. So I need that to be next to its phrase, not below it. So every time I see dx on the bottom, my first instinct should be to get dx out of the bottom. So we're going to start there. So we're going to start by grouping our variables. And my first step to do that is going to be to multiply both sides by dx so I can get it out of the bottom. So we're going to start with dy, 5x squared y dx. So my dx has been multiplied to both sides. Now I'm going to check out where my variables are. I have all my x's on the right, that's awesome, but I also have a y on the right and a dy on the left. So I'm going to take this y from the right and move it over to the left-hand side. And I do that by dividing. So I'm going to divide both sides by y so that I can move it over. So on the left I'll have dy over y, and on the right I'll have 5x squared dx. Now everything is separated. I'm ready to move forward. So for my next step, I'm going to integrate. So to integrate dy over y, I have the derivative of something being divided by itself. The integral for this is ln of whatever was on the bottom. So I have the ln of the absolute value of y on the left. That's an identity, and if you can't remember that one, it's a good thing to study. On the right, I'm just going to go ahead and bring down my 5 and use the power rule that I know for integrals. So I'm going to add 1 to my exponent and divide by that new number. And then I'm going to put my plus c on the right because we're finished integrating. Okay, so at this point, I want to simplify this equation a bit. I do need to have this general solution, so I do need to get y by itself. In order to do that, I'm going to need to eliminate my ln that's in front here, and I can do that using the letter e. E to the power of both sides is going to get rid of my ln. So these guys will cancel, and my absolute value of y will be left over. On the right, I have e to the power of 5x cubed over 3 plus c. But if I have two things in my exponent that are being added together, it means I've got two like bases that were being multiplied. It's just like if I had x squared times x to the 5th. My new exponent here would be x to the 7th because I take the x and I add the 2 and the 5 exponent. So in this case, we're taking our addition and our exponent and we're breaking it back up into two pieces instead of taking two pieces and combining them into one exponent. So I'm going to take these two things in my exponent and break these up into two pieces. I'm going to have e to the 5x cubed over 3 times e to the c power. And just like we saw with multiplying c by a constant or raising c to a power or rooting c, whatever we do to c, it stays c because c just means some number I don't know. So if I raise e to the power of some number I don't know, it just becomes a new number that I still don't know. So this is just going to be c. So the absolute value of y is c times e to the 5x cubed over 3. Now, the very last thing I have to do to get y by itself is I have to get rid of the absolute value signs. And the way that I do that is by understanding what the concept of the absolute value means. It means that whatever is inside here, this y value, could be positive number or it could be a negative number, and no matter what it is, I'm going to get a positive answer because of the absolute value. So because it's possible for this number to be positive or negative, if I take the absolute value signs away, I have to show that this could be positive or negative. So I can put a plus or minus here. So I have plus or minus c times e to the 5x cubed over 3. Now, this is the only thing that I can do to C that does not fit into my definition of what C is. So I can do plus and minus C, that's possible, but I can't just call that C anymore. I can multiply C by something, divide C by something, whatever I want to do, and still call it C, except call it two different things at the same time, positive and negative C. So instead, we take the positive and negative C, and we give it a new name, just so it's easier to write. We're going to call this capital K, and the K stands for constant, just like the C stood for constant. So it's still just some number, I don't know, but it stands for positive or negative C. So my final step in finding the solution is y equals K times e to the 5x cubed over 3. And that's it for the general solution for this problem. We are going to move on to question 4 from the same worksheet. So let's have a look here. In question 4, it's asked us to find the particular solution this time. And this equation is dy dx equals e to the x over y squared. And it's given us the initial condition y of 0 equals 1. And this notation may be something that's a little unfamiliar, but it's basically just saying that my function is a y equals function, and if I want to plug something in, that's when we put it in the parentheses. So when I plug in a number to a y equals equation, I'm plugging in x values. And what comes out of that is my y equals, so this is my y. So if I plug in the letter x, I get out a y. So if I plug in the number 0, I'm going to get out the number 1. So that's my initial condition. Before I can use that, I need my general solution. And before I get my general solution, I again have to start with grouping. So I have y's on both sides, x's on both sides, and I have two fractions. So my first step is going to be to cross multiply. So I'm going to end up with y squared times dy on one side. And on the other side, I will have e to the x dx. Now, just to double check, all of my variables are grouped together. All my y's are on the left, all my x's are on the right, which means now I'm ready to move on to my integrate step. So when I integrate the left, I'm integrating y squared with respect to y. So this is going to use that power rule that we know, y cubed over 3. On the right, I have to integrate e to the x dx. When I integrate e to the x, it stays e to the x. This is one of those rules that you're going to have to memorize. And after I'm finished integrating both terms, I put my plus c. So this would be close to my general solution, but I do want a particular, which means I have to use my initial condition to solve for c. And I can do that now, or I can multiply everything by 3 first. It makes no difference. Personally, I don't like dealing with fractions unless I have to, so I'm going to go ahead and multiply everything by 3 before finding c. But like I said, it doesn't actually make a difference. So I'm going to multiply everything by 3. I'm going to get y cubed. And over here, I'm multiplying e to the x by 3. We just call that 3e to the x. There's nothing else I can do to simplify that. And I'm taking the letter c, and I'm going to multiply it by 3, and it's going to stay c, because again, it's just some constant I don't know. Now it's just 3 times bigger, but I still don't know it, so I still call it c. Now I'm going to use my initial condition to find my missing variable. So I'm going to plug in 0 for x and 1 for y. So this is 1 cubed is 3 times e to the 0 power plus c. Now e to the 0 power, e is just a number. When I raise a number to the 0 power, my answer is always 1. So e to the 0 is 1. So 1 cubed is 1, 3 times e to the 0, which is 1, plus c. So this is 1 equals 3 plus c. And to solve for c, I just have to subtract 3 from both sides. So c is going to be negative 2. If you had solved for c up here before multiplying by 3, you would have gotten c as negative 2/3, which is totally correct, because your next step would be to solve for y, and you do that by multiplying everything by 3. So the 3's would cancel, and you would end up with a negative 2 anyway. So again, it doesn't matter when you do that step. So using my c as negative 2, I'm going to plug that back into my general solution so that I can get my particular solution. Y cubed over 3 is e to the x minus 2. Just kidding, I already multiplied everything by 3. Ha 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 ha, just kidding. So y cubed equals 3 times e to the x minus 2. That's where it's supposed to go back in. The last step before I started plugging things in. Sorry about that. Okay, which means that my very last step to get y alone, which I definitely want to do, I want a y equals equation. The last thing that I have to do is I have to get that cubed out of there, and I do that using a cube root. So I'm going to root this cubed, and it's going to make it go away. Beautiful. Y equals the cube root of 3e to the x minus 2. And that is the particular solution for question 4. So that does it for this video. We're going to pick up with question 5 in the next video.